let's calculate some derivatives. Remember, this time we're finding our derivatives of functions, so our answer should be functions. So we write f prime of x is going to equal the limit as h approaches 0 of 3x plus h squared minus x plus h plus 1 minus f of x all over h. Right, and this will give us, oh boy, I hope we have enough room, 3 times the quantity x squared plus 2xh plus h squared minus x minus h plus 1 minus 3x squared plus x minus 1. Whoops, this is, close that, all over h. Do it out one more time, and we get this, 3x squared plus 6xh plus 3h squared, that's a squared, minus x minus h plus 1 minus 3x squared plus x minus 1 all over h. Now, as expected, all the non-h terms in the top should cancel with each other, because the goal of these problems is always to divide out by h on the bottom. And we can do that if and only if the only terms in the top have an h in them. So let's see if this works out. Well, 3x squared minus 3x squared minus x plus 1 minus 1. Awesome. And now we're just about to solve the problem. 6xh plus, by the way, I'm doing a bunch of extra steps. If you feel comfortable just dividing by h at this point, and like factoring it out, then go for it. All right, I'm just doing some extra steps to make sure that you understand what's going on, right? 6x plus 3h minus 1, right? Don't sleep on that minus 1. That's important. All right, because it's part of our answer, right? Our answer is 6x minus 1. F prime of x equals 6x minus 1. Now, that took a little bit of work. Maybe there's a shortcut, right? Similarly, right, f of x equals the square root of x plus 4. Ugh, lovely. We did a bunch of these during the lecture, so hopefully you could do this one. But if not, well, it's going to be the limit as h approaches 0 of the square root of x plus h plus 4 minus the square root of x plus 4 all over h. Well, you know what we're doing here, right? Multiplying by the conjugate. Over, and I'm just gonna cheat. Just doing it. All right, just doing it. All right, and what are we gonna get? Well, we're gonna get x plus h plus 4 minus x plus 4 all over h times, well, this mess on the bottom, right? Well, look what cancels on the top, the x and the 4, right? They all cancel. And if you see the next step, then just go ahead and do it, but in case you don't, I'll write it out for you. That, right? And then we're going to wind up getting, well, maybe I'll actually do it over here. Wind up getting 1 over root x plus 4 plus root x plus 4, or 1 over 2 root x plus 4. Again, that took a little bit of work, so maybe there's a shortcut. And last but not least, the fraction. Ugh. My least favorite. Maybe I shouldn't say that. They're all my favorite. But fractions, right, can sometimes be the nitty-grittiest, right? They can be the nastiest because we have to do a common denominator. I don't think this one will be so bad, but let's take a look, right? This will be x plus h plus 1 minus 3 over x plus 1 all over h. Right, quickly put that down there. And we get, right, now looking ahead, we're going to need to multiply this by a common denominator, right? Nasty stuff. In fact, I think I'm going to move this stuff over here in case I don't have the room. All right, but anyway, take the limit, all right, we keep going, 1 over h, and then we're going to have 3 times x plus 1 minus 3 times the quantity x plus h plus 1. This isn't terrible. And on the bottom here, we just have x plus h plus 1 times x plus 1. Here, let's just multiply some stuff out. 3x plus 3 minus 3x minus 3h minus 3. All over. All right, now at this point, what cancels? Better be the non-h terms, right? And sure enough, it is. And at this point, I'm going to go ahead and cancel the h's, right? Just because we're running out of space, right? Those h's cancel as well. So we're left with limit as h approaches 0 of, that is a minus, right? Minus 3 all over this stuff. And that winds up giving us negative 3 over x plus 1 squared. And we're done.